Hi everyone, I'm Maverick with OwlKnightsMedia, and today we're going to continue the official Godot Create Your First 2D Game tutorial called Dodge the Creeps on their official docs website. Last time we left off with creating the player, so today we're going to be creating the enemy. Now the enemy, if you're just strictly following the docs, is a very fast thing to do. It's very simple, but it kind of glosses over some high-level topics such as testing your work and some of the math that they get into. So some parts of this tutorial I'm going to go very quickly through, and other parts I'm going to take a little bit more time on just to make sure we're all on the same page. So let's go ahead and dive in. Starting up, we have our old stuff with the player pulled up. I find this a little jarring when I'm trying to focus on something, so I will end up closing it, but let's go ahead and create the enemy first. So first part of the tutorial, it mentions click on the scene and add a new scene. Be careful not to do that in here, because if you press add here, it's going to probably add a child node. We're trying to create an entirely new scene in Godot. So select the top one, hit new scene, then click other node, and we're going to search for a rigid body 2D, which comes with some built-in physics, which we'll see here in a second. Okay, so that created on the left-hand side in the inspector a rigid body 2D. I'm going to rename that as they instruct us to mob. And now I'm going to save it. And the reason I'm doing this is that it creates the scene, and it also allows me to very clearly see that I have what I need. So I'm going to close this other stuff so it doesn't distract me, because most of their things like scripts and other scenes don't close on their own. And I want to make sure that when I'm editing things, like we just saw there, I pulled up the player script on accident. I don't want to accidentally work on that and not the enemy script when the time comes. So I've decluttered my work environment. That's not in the tutorial, it's just the way I like to work. Changing the view up on the top to 2D allows me to preview the scene, so that gives me more confidence. I'm not actually on the player scene, I'm on the mob. I can hover over the node, even without an image added yet, it will display the name, in this case mob. So we're on the right track. Very simple, but I want to make sure that we do this thoroughly. And so the next thing they do is they do have you add children. You click the plus sign in the scene selection, and we're going to add the animated sprite 2D. I'm going to select mob here so it doesn't make this a child of the sprite. Add another 2. The second one will be a collision shape. The order does matter in terms of top down because that's the rendering order. And then for the third one, we're going to add in a visible on-screen notifier 2D. We'll talk about that here momentarily, but you can see it. You can zoom in with your middle mouse wheel, and with your middle mouse wheel, if you click it down, you can also move things in the 2D preview. So we can see this red box. That's not the collision shape like we might have seen just a moment back in the player tutorial. This is actually the notifier. And if you click it, you can see that it highlights. So when this box leaves the area of the screen, and if I zoom out, you can kind of see the outline, it will allow us to connect to a signal. And that box says, hey, I'm leaving. So we connect to that using the scripts, and we say, okay, since the enemy is no longer going to be on the screen, we don't want it taking up computer resources, so we're going to free its queue or really remove it from the universe. In Godot, that's called queue free as a method. We'll see that here shortly. All right, let's start with these caution marks because as a developer, that's what I would do first. So the animated sprite 2D, just like when we were working with the player, we want to go select that node, go to the inspector tab, and add an animation, new sprite frames. I haven't figured out how to make this appear automatically, so I just click somewhere else and back, and that makes it pull up the sprite frames portion down here on the bottom. If we open the art directory, we'll see all these images for the enemy. Every 2 represents frames per animation, and we will have 3 animations. We're going to have these first 2 be the fly animation. So I can double click the name and rename it to fly. I'll press the new animation button twice because I want 2 more. The next one will be swim. And the final one we'll rename to walk. Walk will take the walking animation images. We just drag them over. And same for swim. Drag those over. To preview any of these, such as the fly, we can press this play button. And now I'm just going to select swim and walk so we could see how they're subtly different. I'll go ahead and stop the animation. The other thing the tutorial has you do is change the frames per second on each animation to 3 instead of 5. So you click in that FPS box and just change it to 3, and that should do the trick for each of those 3. We can also see that this animated sprite 2D specifically is fairly large. So sometimes you might do this on the wrong one. Be careful, you want to change just the sprite, just the thing you see. So select that node, go to transform, and in the scale, I think they have you set it to 0.75. So that makes it a little bit smaller. Next up, we have this notification on the collision shape. Again, just like with the player, we want to select that node, make sure that we have a shape. They use a capsule in the tutorial. And we want to make that capsule fit close enough to the size of the enemy sprite. You'll notice though that if you try to make a capsule going side to side, you can't really do it, whereas top to bottom it's much more manageable before becoming a circle. So in order to combat that, the tutorial mentions you can rotate this capsule 90 degrees. It's a perfect right angle. So also under transform here with the appropriate node selected, you can rotate 90 degrees, and now it's side to side. So we'll go ahead and change the size a little bit, make it a bit wider. And there we go. We've got something covering most of the enemy. And it's good to be forgiving to players by not having it take up more space. Okay. Something else they do is they have you select this top level node for the mob, and then they have you change the gravity. And I want you guys to see that instead of just, okay, sure, type it and forget about it. So I'm going to press F6, which should preview the scene that we have pulled up, in this case our monster scene. And we can see that the monster starts in the upper left because that's where it's on here in the 2D inspector, but it falls. So we'll play that one more time. F6, and there it is falling down the screen. Press F8 to stop or press the X. So it's falling because this node type, which is a rigid body 2D, as we mentioned, it comes with certain physics built into it, so we don't have to code it all. Sometimes we don't want everything built in, or we want to tweak the things built in. And that's exactly what we're going to do here. We don't want them to fall necessarily, so we're going to set the gravity scale to 0 so that they're not affected by gravity. To do that, you select the node for mob, and underneath the first couple options here, the third option, there's this gravity scale. I'm sorry, my screen is squished, so if you hover over it, you can read the full name, property gravity scale, and we set that to 0. Now if I press F6 to preview, perfect. The enemy's no longer falling. Okay, back to what the tutorial is talking about. It then goes on to say under the collision object 2D section, just beneath the rigid body 2D section. So be very, very clear. We are not talking about the collision shape. We are talking about the mob node itself having a collision object 2D subsection here on the right-hand side. In there, under collision, they have an array of layers with the highlighted one or the brighter one being number 1. You can add some by just clicking them or remove them by clicking them. And then they also have masks, which are very similar, but they do slightly different things. So if I recall correctly, layers effectively represent the layer that this entity exists on. So this enemy and any enemies instantiated from this thing will exist on layer 1. And as of this moment, they will detect and collide, have physics interactions with anything that is on layer 1, each other and anything else. Since the tutorial doesn't want enemies colliding with each other, it has you click that mask 1 and that deselects it. So now they will exist on layer 1, but they will not detect each other and interact with each other. So that's the simple version. Hopefully I didn't invert them, but even if I did, the concept is the same. One represents the layer it exists on, and one represents the layers that it detects. So if it's not detecting the layer it exists on, then any of its instantiated clones won't interact with each other. So that's what's happening. Okay, they then step through in the tutorial setting up the animations, which I believe we already did. Yes, 3 frames per second. So let's move on. Next up, they have you create the enemy script. So we're going to add a little bit of code. Up here with the mob selected, we're going to hit the add script icon. It will give us an auto-generated name based on the name of that node. Mob is fine. I hit create. If I minimize the art directory that I expanded earlier, we can see that now in our project files area, we have a mob scene and a mob.gd, which is shorthand for mob.gd script file, our code file. Okay, so here's the mob file. I'm going to press save just because I'm neurotic. And we can see that it starts with extends rigid body 2D. We definitely know that that means it comes with extra stuff like we saw with the gravity. Fine. The tutorial has you type in 2 lines of code underneath this ready. So I'm going to copy them real quick and paste it in here. Interestingly, they actually removed the auto-generated portion for the arrow and the void here. You can see the example down here. If I press Control Z, you can see it was there before we pasted in their version. So for anyone very curious, this is just a syntax where they're saying this function will return a type of thing. So if we were returning a number, it would probably say int or number or something like that. If we were returning a true or false, you would type in bool for boolean there. If you're not actually returning anything, then void is a very common term in programming. It just means nothing. I'm not returning anything. So instead of having that, they've just omitted it, which is fine. There is supposedly in GDScript, there is a functional advantage to typing. It makes things faster, but I didn't write GDScript, so I can't prove that. It's just what I've read. And I don't want to harp on it too much because there are a couple of things that I think we need to dive into. So let's start with the basics. What did we just copy paste? This first line is declaring a variable called mob types. And that variable is accessing with the shorthand $. So in this scope, we're accessing this animated sprite 2D node, and we're saying get the sprite frames from that, and then invoke this built-in method called getAnimationNames. As you may guess, the return type of that is probably an array of strings, a list of your animation names. So this variable is going to be a list of names. On the next line, they're invoking that same node, and they're invoking a play method also built in. And then there's this kind of monstrosity of math that's happening here. So I'm going to copy that for right now and try to explain it. The tutorial has these 2 lines. I'm going to try to explain them in a way that I hope is a bit more intuitive than how they do with the tutorial. So I'm going to declare a variable, and I'm going to name it in a way that I think kind of explains what's happening. Random animation name from a list of animations. That's way too long of a variable name, but I want this to be as simple as possible and as human friendly as possible. Then I'm going to paste in that logic there, and I'm going to replace the logic from where it was with the name of the variable. We'll put the variable up so that it is defined before it's used. All right, let me expand a little bit over to the right. So that's what this is, right? It's what are we doing? We're invoking play. What do we want to play? We want to play one of the animations, right? Specifically, the tutorial wants us to play a random animation from the 3 down here that exist. So that's what this math is doing. Let's break it down a little bit further. So mob types is the name of the array that we've declared. So that represents all the mob types or all the animations. Okay. And then it opens up some brackets. So everything in these brackets is actually going to give us back a number between 0 and 2. And the reason it's between 0 and 2 is because encoding array indices, or an index, so this is what it might look like, start at 0. So let's just pretend, I think these actually go in alphabetical order. So if fly is the first animation in our list of 3, then saying mob types open and close bracket with a 0 means we want to take that first one, that fly animation, and that's the one we want to play. If I press F6 to preview this, you can kind of see that that is the one that's playing. This is also not in the tutorial from what I recall, but one way you can troubleshoot things and kind of preview is add a camera 2D to the scene. This is temporary and not part of the tutorial. But if you do that and then press F6 to preview, we can see that that fly animation is playing. And every time I play this, it is always the fly animation because of how I have the code right now. If I pass in 2 here, it should take the third from that list because of we start at 0, not 1. I'll press F6 and we can see there's the walk animation, W being at the end of the alphabet, so it plays that one as the third. If I were to try to pass in a number larger than the maximum we only have 3. So if I pass in, say, or indice 10, it should have a problem and it won't play. It gives me an error code as expected. So that's what's happening here with all this math. So let's rename this to index of animation. Okay. And so now we need to define that because that's not a real thing yet. So I'll define a variable call with that same name, index of animation. And that should go back to normal here. Okay. Now that we've done that and we're seeing this as what the tutorial presents, it should actually be random. So I'll go ahead and press F6. There's the swim. I'll close preview again, swim again. This time it was the walk, right? There's only 3 to choose from, so you're going to get repeats if you keep doing this. But the fact that we had a repeat and then a different one tells me it's not just going 1, 2, 3, 1, 2, 3. It is indeed doing this randomly. So good, it's working, which it should. The tutorial does work. But now we still need to break down this. What is happening? Let's start with the second half. The second half is much simpler. We're taking the various mob types and we're saying dot size, another built-in method to arrays in GDScript. So what this part of the equation is doing is saying, hey, this is going to be however many animations we have. In this case, it's going to be 3. Swim, walk, fly. All right. So knowing that, the first part we can look up in the docs, rand I, and that's going to be a random integer between 0 and like 4.2 something billion, whatever 32 bits equates to. It's going to give you some number in that range. Now, that might sound weird, and it is a little weird. I actually don't like how the tutorial does this, but let's go with it. So you have this random number between 0 and some massive number, and then this modulo sign or modulus sign, it looks like a percent sign. So it's a math problem. It would be like typing in some number modulo some other number. In this case, it's a random number between 0 and 4.2 billion. Give me the remainder once I put in 3. If that doesn't make a lot of sense, that's okay. We're not here to do computer science. We're not here to do math. I just want that to be kind of vaguely understood. So let's go into their docs, press F1, and let's search for the rand I. And they have 2 entries here. If I select this first one, it's not going to have the documentation I want, even though it is accurate. I'm going to select this second one because it has examples of what we're seeing. And here is the documentation pulled up. Rand I, it returns a random unsigned integer of 32 bits, and you can use the remainder to obtain a random value in the interval between 0 and n minus 1, where n minus 1, whatever, blah, blah, blah. Let's look at the examples. It's a lot easier to read than those sentences. So if I do rand I modulo 20, it's going to give me a single number back between 0 and 20 minus 1, 19. So we can see that that's what they have in their example here, 0 and 19. Rand I modulo 100 is going to give me a number, a single number, between 0 and 100 minus 1 is 99. And we can see that in their commentary here. And so on. So in our case, this is what we're writing, but instead of 20 or 100, we're modulating by the size of our array, 3. So it's going to give us a number between 0, 1, 2, and 2. Why 2? Because again, it's n minus 1, right? So 3 minus 1 is 2. So it's going to give us either 0, 1, or 2, which is a format that sounds very similar to the way we index arrays, right? We start from 0, and then the next thing in an array would be 1, even though it's the second element, and the next thing would be 2. So that's what's happening. I know that was pretty complex for something that's fairly simple, but I wanted to make sure that you guys had access to the documentation, examples, and didn't just look at it and go, I'll never be able to do this because this is like advanced level math or something. It's not. And in my opinion, it's way too complicated for this type of tutorial, especially because, first of all, it works, but I think it's too complicated because it doesn't need to be perfectly random. And we could easily just do something like declare a variable of random value. And instead of doing it with rand I modulo dot size on the mob types, we can just do a range, which is another built-in function that we can invoke using GDScript. And we want that, we know what the range is. It's between 0 and however many our index gets up to. So 0 and 2. And that should actually give us the exact same thing as the next line on line 8. And so I'm going to test that theory for just a moment. I'll rename that line and comment out its duplicate. So now we're using this alternative way to determine a random number between 0 and 2 that I think is much more human friendly, much more readable, and much more appropriate for this type of tutorial. So let's go ahead and press F6 to preview. We can see we have swim. I'll press F8 and F6. Now we have fly. F6 again, fly again. Okay, so this feels random, or at least as random perceptibly, you know what I mean, as what we're trying to get done. So that is not in the tutorial. I am sure that someone who knows more than I do, either about computer science or GDScript or Godot in general, might have a reason to prefer this second method, but I would still assert that for this type of tutorial, it's rather inappropriate, especially when you have 2 lines of code. Very impressive for whoever made it. Obviously skilled. I'm not attacking you. I just don't think it's, excuse me, there's a gnat on my glasses. I don't think it's quite appropriate. So let's just press forward. I'm going to undo my changes and get back to how the tutorial is so we do not get too far out of sync. So let me do that right now. I'll just go ahead and wipe out my changes, recopy their thing, and paste it back in. Press save, preview that, make sure it's still functioning. Looks good. I'm also going to remove this camera 2D for right now. And science experiment, I don't know if just making visibility toggle. No, I didn't think so. All right, so I'm actually going to remove it like I thought I was going to. Select it, press delete. All right, we should now be back to where the tutorial was. I apologize for the segue. I just felt that this was way too complex and could intimidate newcomers for their first 2D game. Okay. Next up, they have you connect your signal coming from the visible on-screen notifier 2D node to this script so that you can tell when the enemy goes off the screen and then remove it from the game so it doesn't take up resources. They don't actually specify how to do that, and there's more than one way. So I'm going to do it the way that I presume they want you to do it, which is by connecting a signal from the node inspector. So select the visible on-screen notifier 2D. On the right-hand side inspector, select node. There are two subcategories, signals and groups, and we want signals. And here we can see the screen exited signal. Double-click that, then select the mob entity itself, and that should auto-generate a method for us when we hit connect, and there it did. It'll also add 3 icons to make it well known as you're working that you've established a signal. This green icon next to the function. The node inspector will have a green icon as a child of the signal you just connected to, and the node itself will have an emission signal connected to it as well. So very intuitive, very user-friendly, so we'll go with this method. Then they just simply have you place in the logic there to free up the resource, which in Godot is a built-in method called queueFree. And what that's going to do is remove this whole mob instance from the game should it leave the visible screen. And that's kind of where the tutorial stops. So if you want to move on to the next part of the tutorial, please feel free to click on my next video, which should be out shortly, if not out already. However, I want to take a moment to do what I think any regular developer would do or should do, which is verify our work, at least as much as is reasonable here. So right now we're in a state where we're done with that part of the tutorial, but it's just kind of like, I hope I did everything right. I hope I copy and pasted or typed everything correctly, and that it's all just going to work at the end. I want to see this. So what I'm going to do is I'm going to add, again, not in the tutorial, I'm going to add a print statement, and I'm just going to type in freedom. Let's do a classic, hello world. And that should go to my logs should the notifier get invoked, right? If this function happens, we should see that line first. And for this to happen, if everything's correct, it's because we've successfully connected to the signal and the enemy has exited the screen. Now, if I press F6, that's probably not going to happen, and it's not. And it's not happening because we haven't actually left the scene. So to make this much more intuitive, I'm going to go into the delta process, and I'm going to use the built-in attribute of position, which is a vector 2. And just consider this like an X and a Y value. So vector 2 of 100 pixels to the right and 100 pixels down. And then I'm going to multiply that by the delta so that my computer doesn't cause this to happen instantaneously. I think that's all we're going to need. I'm going to press F6, and what I'm expecting to happen is to see the enemy move from where it starts in the upper left corner over and down, so diagonally down the screen until it leaves the view of my screen, and then I expect to see that print hello world in the output. So let's go ahead and press F6 to preview. There it is. It's doing the fly animation, I think. It's now left the screen, and there's the hello world. So I'm going to close that, undo my changes. I think this was just defaulted, so I'll put pass back here. And I will remove my console log or print statement in GDScript. Save that. Press F6 to make sure it's not moving still. Okay, great. And the other thing I wanted to verify is skipping my mind, so give me one moment to think. I will probably have to edit out my thoughts here, but that's okay. The main thing I was trying to do was see that our work was happening as we expect it to, because it's very easy as you're working and developing in a more natural environment outside of tutorials to make mistakes or for things to not work exactly like you think they're going to. So I think it's important to have these additional tools in your tool belt to troubleshoot not only your own work, but to verify that you're doing things the way you think you are, even if you're following a tutorial. It gives a lot of positive feedback. That's my own personal opinion. And I can't remember what else I was going to cover, so it can't be super, super important. I'll add an editor's note if I do remember, but this is good enough. We've completed the tutorial. We've walked through the math involved. We've walked through some of troubleshooting steps and things you can do on your own. And so that's it for now. Thank you very much. This ends our portion on creating the enemy. Next time, if we take a little preview, we'll be creating the main game scene for the game. So that should be exciting. Thank you again. I'm Maverick with OwlKnightsMedia, and we'll see you in the next one.